Okay, now that we have learned how to solve 1 and 2 step equations, now we are going to review and then move on to solving 1 and 2 step inequalities. In the past, what we've done is we would, if we see an addition equation, we're going to solve by doing subtraction. We'd get x equals 6 for our answer. We could go back and check. Does 6 plus 7 equal 13? And since it does, we're good to go. With subtraction equations, you'd add. We'd get x equals 18. We could check. Does 18 minus 8 give us 10? And since it does, we're good to go. On the next page, we have some multiplication and division equations. 12 is connected to the y by multiplication. To undo that, we were going to divide. So we get y equals 12 for our answer. To check, 12 times 12 does give us 144. This one I'm going to rewrite because I don't like it when it looks that way. I'm not sure why. So this is a division equation. We'd have to solve by multiplication. We'd get a equals 72. And 72 divided by 8 does give us 9. Now with problems like this next one, whenever we have a fraction next to a variable, we want to multiply by the reciprocal. So I'm going to multiply both sides by 7/3. Okay, 7s will reduce, the 3's will reduce, we're left with x. And here we've got 21 over 1 times 7 over 3. The 21 and the 3 could reduce to 7, and 7 times 7 would give us 49. When we talk about inequalities, we're talking about these symbols right here. Remember, this is less than. This is greater than. This would be less than or equal to. And this would be greater than or equal to. And what these two mean is if I said that x is less than or equal to 4, that means that x could be 4. But if I said x is less than 4, it cannot equal 4. It's everything leading up to it, but not including. So here we could say 4 is less than 9 or less than or equal to 9. Negative 6 is greater than negative 10 or greater than or equal to negative 10. Negative 30 is less than negative 20, or we could say less than or equal to. 11 is greater than negative 11, or greater than or equal to negative 11. And again, those are our inequality symbols. Circle each number that satisfies the inequality. So what could we plug in for x that's greater than negative 5? Negative 15 wouldn't work. Negative 10. Negative 8 wouldn't work. Is negative 5 greater than negative 5? No, it's not. We would have to have the equal to sign in there as well. And the rest would be greater than negative 5. Mark 8 less than 5 cupcakes. So the number of cupcakes that mark 8, we'll call x, would have to be less than 5. Mickey saw more than 4 squirrels. So the number of squirrels was greater than 4. And you can use whatever variable you want for these. The elevator could hold at most 2,000 pounds. So the elevator is going to be less than or equal to 2,000 pounds because you'll see at most it can hold that 2,000. Nick ran at least 3 miles. So Nick ran greater than or equal to 3 miles because if he ran 3, that would be the minimum. Now we're going to get into solving these equations and we're going to show you exactly how to graph it. A couple things first. If you have a sign that's less than or greater than, then you are going to put in an open circle. If it's less than or equal to or greater than or equal to, you are going to put a closed circle. And what I say to help people remember what you do is that the first ones, the less than and the greater than, have less lines, so you have to do less work. You don't have to fill in the circle. The less than or equal to and the greater than or equal to have more lines, so you have to do more work by filling in the circle. So this first one, we've got x is less than negative 3. So I'm going to look here, and I'm going to plot an open circle at negative 3, and any number that's less than negative 3 would be over on this side of the equation. What I do is I look at this, and I turn as long as the x is on the left-hand side, I turn this middle sign into an arrow, and it tells me what way to shade. So and you could check to see, is negative 10 less than negative 3? Yes, it is. Is negative 8 less than negative 3? Yes, it is. So it tells us that everything to the left of this point is less than negative 3. The only difference with this next problem is that it could include negative 3. So since it's that less than or equal to sign, we have to fill in our circle. And again, I make that into an arrow, and there we go. When you get to the level 2 type of problems, it's just solving like a regular equation, but then graphing it on the number line. So in this first case, I would subtract 17 from both sides, and I get x is less than 5. Since it's less than, I need an open circle. I'm going to turn this into an arrow, which means I've got to shade this way. And all these numbers, 4, 3, 2, 1, 0, all the negatives are less than 5. The next one I'm going to change to the keep it, change it, flip it. So that really is x plus 3 is less than negative 4. We subtract 3 from both sides. We get x is less than negative 7. Since it's just a less than sign, we're going to have an open circle. The numbers that are less than negative 7 would go to the left. And if I looked at this sign, I could turn it into an arrow, and it tells me which direction to shade. Got a couple more examples with addition and subtraction equations. So we add 6 to both sides. We get x is greater than or equal to 8. So it's greater than or equal to, more lines, more work. I've got to fill in my circle. With the greater than or equal to, if I turn it into an arrow, it's got to go to the right, and all these numbers are greater than 8. Add 14. X is greater than 5. Just greater than, so I'm going to have an open circle. The numbers that are greater than 5 are all over this way. Here we've got multiplication equations, so we're going to divide on both sides. Here we get r is less than 5. It's less lines, less work, and we have to shade to the left. Divide by 2. R is greater than or equal to negative 2. I'm going to go to negative 2 and fill it in. More lines, more work. And we have to do greater than negative 2. The numbers that are greater than go to the right. I'm going to rewrite these ones because, like I told you before, I don't like how they look when they are just typed like this. So we're going to multiply by 2 on both sides, and we get x is less than 6. So I'm going to put an open circle, and all the numbers that are less than 6 go to the left. Multiply by 2, multiply by 2. X is greater than or equal to negative 8. So we go to negative 8. We have to put a closed circle this time. The ones that are greater go to the right. So you're going to learn about a special case, and I can't really maneuver this slide like I could on the smartboard. But basically, what happens is when we multiply by a positive, like let's say we chose the numbers 1, 2, 3, and 4. If we multiplied each of them by a positive, they'd stay in the same order, like smallest to greatest. It'd give us 2, 4, 6, 8, but we still have smallest here and largest here. Down here what happens, we've got negative 2, negative 4, negative 6, negative 8. Instead of going from smallest to largest, we're now going in the reverse order from largest to smallest. So what we have to do is we have to switch our sign whenever we multiply or divide by a negative number. So I'm going to rewrite this one up top. We've got negative 2x is greater than or equal to 4. Since I'm dividing by a negative, my answer has to switch my sign. So instead of being greater than or equal to, I have to switch it to less than or equal to. So x is less than or equal to negative 2. So whenever we multiply or divide by a negative number, then we have to switch our sign. So I'm going to plot our new one. It's going to be at negative 2. It's going to be a closed circle. And it's going to be less than, so we're going to go to the left. And if I checked a point to make sure that I was right, what I'd do is I'd just take, let's take negative 5, okay? So this is just an example. I'm going to check negative 2 times negative 5. Is that greater than or equal to 4? Is 10 greater than or equal to 4? Yes. If we didn't switch our sign, let's pretend we kept it as greater than or equal to negative 2, then we'd be working with these numbers over here. We'd check, is negative 2 times 0 greater than or equal to 4? Is 0 greater than or equal to 4? And no, that would not be true. So you have to make sure that you switch your sign. So let's fill this in. When solving inequalities, if you multiply or divide by a negative number, you must reverse or flip the inequality sign. So when we get to this next page, I'm dividing by a negative, and what happens when we divide by a negative? We have to flip our sign. So now it's going to be x is less than or equal to a negative, and a negative is a positive. It's going to give us 3. So I'm going to fill in my circle, more lines, more work. Less than 3 is going to go this way. I'm dividing by a negative, and when we divide by a negative, we have to reverse our sign. X is greater than negative 5. So I'm going to put an open circle. Greater than would be to the right. Okay, so now I'm going to rewrite this because I don't like the way it looks. X divided by negative 3 is greater than negative 2. Now I'm multiplying by a negative, and what happens when we multiply by a negative? We have to reverse our sign. So x is less than negative, and a negative is a positive 6. So I'm going to put an open circle, and all the numbers less than that go this way. X divided by negative 2 is less than or equal to 4. I'm multiplying by a negative 2, which reverses my sign. So x is greater than or equal to negative 8. Putting a closed circle, the numbers that are greater go to the right. Okay, here we've got negative 1/2 x is greater than or equal to 3/2. We're going to multiply by the reciprocal, which is a negative. Multiply by 2 over negative 1, so I have to reverse my sign. X is less than or equal to 3 times 2 is 6. 2 times negative 1 is negative 2, which means x is less than or equal to negative 3. I'm going to graph that. It's got to be a closed circle. The numbers that are less than that go to the left. Here we've got to multiply by the reciprocal. My question for you is, do we have to flip our sign? Are we multiplying or dividing by a negative number? And we are not. So it's going to be x is less than 28 over 10, which would mean x is greater than 2.8. So I'm going to go in here about 2.8, and it's greater than, so we're going to go to the right. Here, it's kind of hard to see this. This is 33/4. Not sure why there's such a big space. So what we would have to do is we'd have to add 33/4 to each side. Over here, it's going to cancel out. We get x is greater than or equal to. Now, our denominators are not the same. So what I'm going to do is I'm going to make this 66/8. 66 plus 23 is going to give us 89/8. And that would be 11 and 1/8, which isn't on here, so we just continue down. 11 and 1/8 is going to be about right here. Filled in circle. And I'm going to just extend this and go to the right for the shading part. The numbers that are greater than go to the right. There we go. It says an engineer is designing a rectangular parking lot that is to be 50 feet wide. So I'm going to just draw this rectangle. It's 50 feet wide. According to the city building code, the area can be at most 3,500 feet. So the most the inside could be would be 3,500 max. So we want to figure out what is the allowable length. So we would say 50, our width, times our length, we'll call L, can be less than or equal to 3,500. So I'm going to divide both sides by 50. And our length would have to be less than or equal to 70. X, we called it L, stands for length. Perfect. If you have any questions, feel free to email me. This would be the best way. And we'll see you tomorrow.